This is just a small segment of the hundreds of feet of hydraulic hose in this excavator. In addition to carrying hydraulic fluid, this hose is also storing and carrying contaminants. This is a piston pump. It's no longer pumping any hydraulic fluid. It failed because of too much contamination. This excavator sits idle and unproductive since an excessive level of contaminants entered the system and went unaddressed. Even before a breakdown, contaminants in fluid can reduce system efficiency. That is as true with fuel and engine oil as it is with hydraulic oil. A less efficient system is a less productive system. These productivity losses can go undetected because the efficiency loss is slow. In hydraulic systems, for example, efficiency can drop as much as 20% before the operator detects a change in operation. That's losing a day of productivity each week. There was a time when hydraulic pressures were much lower than they are today. Clearances between internal metal-to-metal surfaces were not as tight, and we were more concerned about contaminants we could see. But as customers ask for more power, higher breakout forces, and faster cycle times, our industry is responding with more sophisticated fluid system designs. Higher pressures, tighter clearances, and electrohydraulics have made today's products more productive and easier to operate. However, they've also increased the need for clean fluid systems throughout the life of the product. We now need to be concerned about dirt and other contaminants we cannot see. Particles as small as 2 to 5 microns. That small a measurement is difficult to comprehend. In order to visualize what 5 microns in diameter is, let's start with the smallest particle most of us can see. That is the speck of dust you see on your television screen, which is 40 microns in diameter. You might conclude after a quick glance at the numbers that a 5 micron particle is 1/8 the size of a 40 micron speck. But to properly compare size, you must relate the cross sections of the particles, not the diameters. As you can see in this representation, the 5 micron particle is actually 1/64th the size of a speck you see on a TV. Due to the tight clearances in today's systems, that small a particle can be the beginning of premature wear and efficiency loss. And it doesn't take too many particles to contaminate a system. This small amount of dirt in 55 gallons of hydraulic oil exceeds the contamination allowed in the hydraulic systems of new Cat machines. Contaminants can take many forms. These include such things as dirt, sand, paint, metallic wear particles, and even fibers off rags. In fact, contamination is anything that does not belong in the system. These particles look like this in dirty oil. A microscope reveals the actual difference in appearance between dirty oil and clean oil. Small particles can take advantage of a lot of opportunities to enter a closed fluid system. They can get in when the component or machine is built, during the storage or transportation of new oil, during maintenance and service when the system is open for repairs or oil changes, and during machine operation, such as around worn wiper seals, or when attachments with dirty connectors or dirty oil are changed. Contaminants do not have smooth edges. They are irregular in shape and have sharp edges that cause abrasion as they scrape metal surfaces, creating additional contaminants. Let's follow contaminants in the hydraulic oil as it is drawn from the tank through the hose to the pump. You can see the contaminant's irregular shape with sharp edges and corners. Once the oil and contaminants are drawn into the rotating group of the pump, the contaminants can cause damage in several ways. The larger particles cannot pass through, but will break up as they strike the stationary port plate, shown here in yellow, and accelerate wear. Notice how the contaminants break down the edges of the port plate. As we look at other ways contamination can cause problems, we turn the animation of the pump 90 degrees onto its side. Particles can lodge between the piston and the brass slipper foot, seen in purple, causing it to jam. Or the contaminants can scrape walls between the barrel and piston. Electro-hydraulic valves are more susceptible to contaminant damage because the clearances are even smaller, as small as 3 to 4 microns. Some of the particles naturally adhere to the imperfections in the wall, or because of the electromagnetic conditions in the valve. This buildup or siltation can either slow the spool, causing sluggishness, or make the spool hesitate, causing jerkiness in the system. Over time, the contaminants can cause wear on the spool that results in leakage. And sometimes a large particle can become lodged and block the motion in the valve. Contamination already in the system moves on to hydraulic cylinders, where additional dirt can enter the system because of nicks in the cylinder rod. A wiper seal in good condition will prevent much of the dirt from entering, but contaminants down in the nicks can move past the wiper seal into the cylinder. Once past the wiper seal, the contaminants are now able to move freely within the hydraulic fluid. A nick in the cylinder rod is not the only way dirt can enter the system. It can enter on the surface of the rod due to a worn wiper seal. These particles can scratch the cylinder wall, creating more particles and accelerating wear to the piston wall and seals. All these particles then move on to the filter. Do not assume the filter removes all contaminants in a single pass. As the oil moves through the filter media, many of the particles are trapped, but a few, some large and some small, travel through the media and return to the system through the center tube. Even high-efficiency filters do not remove all contaminants. Contamination can affect any machine with hydraulic capabilities. A hoe that swings too far on a backhoe loader, or one track that unintentionally runs faster than the other on a track-type tractor can be a sign of contamination. Equipment owners and operators also see other common effects of hydraulic system contamination, including cylinder drift, jerky steering, slower performance, erratic operation, shorter service intervals, higher operating costs, lost productivity, and possibly catastrophic failure. The pump is one of the most expensive components to fix in a hydraulic system, and in the event of a catastrophic failure, it may take days or even weeks to repair a contaminated hydraulic system. But contamination harms more than just hydraulic systems. For example, contamination can affect the control valves that regulate the amount of oil going to the clutches in transmissions. Contaminants can make the valves stick or plug the orifices. That will result in harsh shifts or the inability to shift. If the differential housing isn't properly cleaned when new or rebuilt final drives are installed, the remaining contamination in the housing will contaminate the final drives, causing leaks and premature wear. In fuel systems, clearances are smaller, as small as 2 microns. This inside view of a 3500B injector tip shows how very small contaminants have clogged 4 of the 8 orifices, restricting proper fuel injection and causing loss of power. Dirty fuel is the largest cause of fuel system failure. To reduce contamination, Caterpillar is committed to designing and building clean components and machines, and providing information, tooling, and training to help dealers and customers maintain clean components and machines. But it takes a joint effort at all levels to control contamination, starting with the contaminants you can see. Keep floors and work areas clean. Protect parts during assembly, repair, and storage. Clean hoses during assembly. Store fluids properly. Filter all fluids. protect machines during operation, and during preventive maintenance. Take oil samples at the recommended intervals using proper techniques, and regularly use particle count technology to monitor and trend contamination levels. Contamination control is no longer an option. Without a full commitment at all levels, contamination will continue to be a silent thief, robbing fluid systems of performance and increasing downtime and costs. Caterpillar, suppliers, dealers, and customers all must work together to keep contamination in check throughout the life cycle of the product. Together, we can be the leaders in contamination control. Together, we can help keep CAT products the leaders in performance and reliability.